Alrighty, so we're gonna do the a quick overview of what if you were absent for the measurement lab. So the first one says what's the length of the table. I have my meter stick here, I have my table here, and so I'm gonna measure it. And so if I have my meter stick and then I go down, and then I remember where that spot is. So then if I go to there and then I go to the end, then it would be 152 because it was a whole meter and then a little extra, and then it says to measure it in inches as well. So if we go down here, we have 39, and then remember where that spot is, and then go down to here, so we'd have 39 plus about 20, and so that would be 59 inches. And so then it says measure this line, and so that you can do with a ruler, and then convert it to kilometers and meters, and then measure yourself. If you have a yardstick or a meter stick at home, you might have to do some conversions. And then find 4 friends and figure out how tall they are, and then make a little bar graph of those heights. And so then on the back, it is about mass and volume. And so these are gonna be a little bit out of order, but I put them, I'm just gonna go in the order that I had them around the room. And so on number 8, which is the first one, we're gonna start on mass number 8. We're gonna turn on our scale, and this is what is the mass of 10 milliliters of water. And so if we put that on there, and we push this out to 0, because we don't care about the weight of the graduated cylinder, we care about the weight of the water. And so we put some squirts in here, and we'll get up to 10, which is that line right there. And so then you would record the weight. So 9.70, and that is grams, if you see that right there. Okay, next one. And so this is mass number 7. And so the question on this is, how do you measure the mass of the marbles? What is the mass of the 5 marbles? So you just need to explain that we're gonna take our scale, we're gonna turn it on, maybe. And then we're going to put our little dish on there, and we have to use the little dish because otherwise our marbles would roll everywhere. And so then you zero that out to get rid of the mass of the dish, and then you'd have your 5 marbles. And so then the mass of the marbles is 21.92 grams. Next one is number 14, and this is asking about a volume question. So it says, fill the pipette with water, empty it into the small graduated cylinder. Repeat this step 6 times. What is the volume of 1 pipette? And so I don't know if you can see this on here. Hopefully you can. It says 1 milliliter. And so we're gonna fill that up to that line. We're gonna fill that up 6 times. And so 2, 3, 4, 5, 6. And I did that quick, but hopefully I did an okay job. And then if we look on here, it says about 5.5. Now maybe that was me because I went quick, and maybe it's just the pipette. So the second part of that says, how accurate is the pipette compared to the graduated cylinder? And so this is a piece of plastic that's sort of mass produced that I kind of eyeballed, and has big graduations between the two things. So, and this has relatively small and a bunch of different things. So what do you think? What do you think is more, what do you think is better, more accurate, more precise? So think about the things that we talked about last week. So moving on over here. And so now we have number 9 and 10 on volume. And so this says, using displacement, what is the volume of in milliliters of 5 marbles? And so we're gonna take this, and displacement is, I'm gonna put in some water. Try not to make too big of a mess. But I wanna do it so my math is easy. And so I'm gonna get it at 40. And so if you look here, the line is, let me do a little bit better job than that. And so my meniscus is right at that 40. And so then I have 5 little marbles here. And so I'm gonna drop them in, and then I'm gonna see. Ooh. And so then I have, it says 49. So then my volume of my marbles is 9, because I started out with 40, I ended at 49, so you take the difference. So on your paper it says displacement is a final minus initial value, and so it allows us to find the volume of irregular objects, which is our marbles. And so then it would be 9. And then the other one, the next one says, calculate the volume in cubic centimeters of one marble, where one marble, or 1 milliliter equals 1 cubic centimeter. And so you need to do a little bit of math with your 9 milliliters and your 5 marbles, but you should be able to do that. And so the next one is volume number 12. And so it says, which tool is more accurate, a beaker or a graduated cylinder? And so if we use this, we have like a cup of water here, and I gave you some stuff to sort of fiddle with. And so if we put this in here, and I'll try to get this as close to 20, well, I'm gonna go 20, and then this is a, whoops, this got moved. That's why it's not making sense. Oops, sorry if that made you dizzy. And so this is a 25 milliliter graduated cylinder, and I'm just gonna pour this water into there, see how good, oh, that's not right. Oh my gosh, that's the cup. Oopsie. And so this should be 20. And so we'll pour this in and see how good our beaker is. And so then now this says 19. And so this said 20. We were right on that line, and this is 19. So again, which one's better, more accurate for measurements? And then this next one says it's mass number 5 and 6. So it says, what is the mass in grams of 5 pennies and 10 pennies? And so you just need to, you don't have to use the little dish, which I gave you a little dish just to put the stuff in. And so if we have 5 pennies and 10 pennies, and so you might say, well, if it's 5 pennies, then it's 12.51, and then so it's going to be 25.02, 25.02. Let's keep that number in our head, 25.02. And so it's not really. And so pennies vary in weight, so then 10 would be 25.62. Now the reason is because it used to be pennies were all made of full copper, and now they're not. They're filled with zinc, and zinc has a different weight than copper does, so then the pennies weigh different amounts depending on what year they're made. Next one is the volume in number 13. So this little flask, which is pretty like, oh, biology, science. We use, these are called Erlenmeyer flasks, and they're really cute, but they're not very useful. And so let's fill up our beaker with, we'll say 40. Try and get that pretty close, so 40 milliliters. And then, well, let's do 50, because that first line on that Erlenmeyer is a 50. And so, so if we have, get it up to that little line. Oops, I'm out of water. Oopsie. So I'll put this in, try and fill that up a little bit. So that's rated about 50. And so then on here, we'll see how close we get. And so, wow, that still looks pretty good, doesn't it? I don't know if you can tell, but it's right on that line. And then the always accurate and precise graduated cylinder, then we measure, and it looks like it's like 52 or 53. And so neither of these are really great. They're cute, and we can store stuff in them, but for real precise stuff, we use a graduated cylinder. And so last one, then I gave you a little beaker, and I put some purple water in it, and so it has about 60. Hopefully you can see that. And then if I put it into here, probably guess by now that it is not going to be 60. It's actually going to be like 54, 56. And so we always use graduated cylinders when we need precise measurements because they work better. Hopefully that helps.